So far, we've understood the logic of price determination in the sense that we've seen that supply and demand determines the price of goods in some markets. And then we spent a while looking at the nature of the demand curve to try to get a better understanding of the way in which consumers behave in order to see why the demand curve is where it is. Now we're going to turn to the supply curve and try to understand what it is which means that suppliers will only put more on the market when price is higher. What causes us to have an upward sloping supply curve? And we're going to find that the basic answer to that is to be found within business costs. Firms have to cover their costs of production in order to be willing to stay in the market. So the key now is to understand the relationship between the amount of output a firm produces and the costs of producing it. So that's where we're going to start. And of course, each firm's relationship between output and cost is going to be different. The costs of production as firms increase their output in some industries will clearly be different than in others. But there are certain underlying principles which will control the relationship between output and costs for more or less any business. And it's those basic underlying principles that we're going to look at in this lecture. Now, as we do this, we're going to make a fundamental distinction, and it's crucial that you understand this distinction because it's going to underlie everything that we do. And the distinction that we're going to draw is between short-run costs and long-run costs. And when we talk about this distinction, we do not mean that the short run is not very long and the long run is quite a long time. It's not that. There's a very clear and precise distinction between the short and the long run. And the distinction is this. When firms produce output, they need resources. They have to employ land, labour, capital, materials, and so on. The short run is the period of time in which at least one of these resources is fixed. We might think of land or capital. The long run is the period of time in which any of these resources can be varied. So let's make sure that we understand that by thinking of a few examples. Some car firm is experiencing a large increase in demand for its vehicles. Can it increase its output? It can do so in the short run by working the existing capital harder. There is some plant here and people are working on it to produce these cars. Demand is increasing, so we'll work that capital more intensively. We may introduce a night shift or whatever, add more labour to that fixed amount of capital. And as we do that, we can increase output in the short run, work the existing capital more intensively. If demand is falling, we can take this fixed amount of capital and work it less intensively, give up the night shift because we're in a recession and demand is falling. In the long run, we can change the volume of capital as well. If demand is rising, we can go and build a new car plant, or we can close down some of the existing plant if demand is falling. So in the short run, we've got a fixed volume of capital. We can change output by working that capital harder or less hard. In the long run, we can change any factor of production to change output, including labour and capital. And that's going to apply for more or less any business. On a much smaller scale, you're a hairdresser and you have one room in which you're employing a number of people to cut hair. Demand is rising, you can add more labour and bring in an extra hairdresser. In the long run, you can go and buy another shop. So the distinction between the short and the long run turns upon whether the volume of capital or land is fixed. So first of all, we're going to start off by thinking about the relationship between output and costs for a firm in the short run. What happens to costs of production in the short run if you try to increase output with a fixed amount of land or capital? Now, in the short run, there are two kinds of costs. We have variable costs and fixed costs. Variable costs are the costs which vary with output. So we wish to expand output, we need to take on more labour. So the extra labour is a variable cost. If we're a farmer, we may need more fertiliser. That's a variable cost. To increase output requires us to use more. There are some costs which are fixed. Those are the costs associated with the capital. You're a farmer, you've rented some land, and it doesn't matter how much or how little output you produce, you've got to pay the rent. And so as you increase output, your fixed costs don't change. It's not that your fixed costs never change. Next year, the rent might increase. The key is that for fixed costs, when you increase output, it has no effect on the level of those costs. The costs, the fixed costs, are independent of output. So having understood that, we're now in a position to see what's the relationship between output and costs. First, the variable costs, and then the fixed costs. So let's think first of all about the relationship between output and the variable costs. We'll do it via the use of a simple example. You are a farmer and you are growing some particular crop. It might be cabbages. And we ask, if you work the existing land more intensively, what happens to the costs of growing more cabbages? Well, it goes like this. If you don't have any output, you don't need to employ anybody. You have zero variable costs. And clearly to increase your output means more labour, so your variable costs rise. So in general, as output increases, variable costs increase. But we don't think that variable costs increase at a constant rate. We think that what's going to happen is likely to be something like this. When you first increase output from a low level, your costs rise relatively slowly. Each extra unit of labour you employ, you have to pay the wages. But the extra output that you get from these additional units of labour are highly productive. Maybe 1, 2, 3 people working together can do things that one on their own can't do. So you employ one extra person and product rises very rapidly. You only got to pay him the same labour. So the costs of increasing your output are going up relatively slowly. But now it's inevitable, isn't it, that if you go on adding more labour to a fixed amount of capital or land, it becomes harder and harder to increase the output. By the time you've 4, 5, 6, 7, 8 people working on a field to produce the cabbages, the extra person employed is going to produce very little extra output because he hasn't got much field to work with. So the costs are rising because you have to employ him and you're not getting much extra output. So variable costs begin to rise very rapidly. If you're the hairdresser and you employ an extra person, there comes a point where the poor guy who is now employed has got hardly any room left in the shop. He can barely move his elbows. So he's not very productive. he doesn't produce many extra haircuts in the week, you're still paying him the labour, the price of the labour. And so the cost of increasing these haircuts is actually going up very rapidly. This idea we call the law of diminishing returns. The returns to the extra unit of labour is declining. The law of diminishing marginal returns. Now, if you've understood that, we can now look at the diagram and see the relationship between output and variable costs. At zero output, we have zero variable costs. As we increase output, costs rise, but at first they rise relatively slowly. But beyond some point, the marginal product of labour is very low. It's harder and harder to increase output. You still have to pay the wages, and so you find that your costs start rising very rapidly. So the diminishing return sets in at some point, and total variable costs increase rapidly. So here's our relationship between output and total variable costs for a typical firm. Now, so far then we've thought about the relationship between output and variable costs. Now let's think about the relationship between output and fixed costs. What happens to the fixed cost as you increase output, the cost of the rent of the land or whatever? And as we've already seen, as output increases, the fixed costs don't rise at all. So let's see if we can draw now the relationship between output and fixed costs. We'll do this on the same diagram. At zero output, we still have some fixed costs. We have to pay the rent, even if we don't produce anything. But as we increase output, those fixed costs don't change. The rent stays the same because the person who's renting you the field wants the same rent regardless of the amount of output that you produce. So total fixed costs vary with output in that way. Now, all costs are either fixed or variable. So if we want to know the relationship between output and the total costs in the short run, it's simply a question of adding the fixed to the variable costs, and we can see the relationship between output and total cost. Total cost in the short run is fixed costs plus the variable costs. So diagrammatically, it looks like this. Total costs at zero output are all fixed costs. As we increase output and we sum the fixed to the variable costs, the short-run total costs are simply the variable cost displaced upwards by the amount of the fixed costs. So we've got the relationship between output and fixed costs, output and variable costs, and output and total costs. Now, of course, for any particular firm in any particular industry, the relationship between output and short-run total costs is going to be different, but this principle of the law of diminishing returns is going to apply to just about any firm in any industry. So we've now got the relationship between output and short-run total costs. But we're going to see in a later lecture that it's really useful if we understand the relationship between output and average costs, costs per unit of output. And we can work this out very simply. If we know the relationship between output and total costs, we can simply divide total costs by the number of units produced, and that will give us average cost at any particular level of output. And once we've understood that idea, we've only got to look at the short-run total cost curve of the firm, and it quickly becomes obvious what the relationship is between output and average cost. So let's do that now with the diagram. Here we have our relationship between output and short-run total costs, with some fixed costs here that we've got even at zero output, and then variable costs, meaning that as output increases, short-run total costs rises in that way. And underneath, we're going to plot the relationship between output and average cost. So, for example, at 5 units of output, the total costs are, say, £60. Then what's average cost? We simply say that at 5 units of output, average costs are 60 divided by 5, which is £12. So £12 a unit is average cost at 5 units of output. 10 units of output, total costs are £100. So on average, if we divide £100 by 10 units of output, then average costs are £10 a unit, and so on. Now, actually, what would be nice would be to see how we can easily get the relationship between output and average cost without spending hours on the arithmetic. And we can do so very simply by observing that at 5 units of output, we've divided this distance here, the total cost, by this number of units of output, 5, and that gives us the slope of that ray from the origin, which is average cost. At 10 units of output, if we divide £100, this distance here, by the 10 units of output, 100 divided by 10 gives the slope here. It's a less steep slope, so the average cost is lower. Now, it may not seem obvious to you why we can find average cost by looking at some ray from the origin. But if you think about that in some other context, it becomes reasonably easy to see. When you drive your car along the road, you come to a hill and you see a sign, and the sign says, hill ahead, 20%. 20% of what? What does it actually mean? Well, think about it and you can see the answer. Here we are, you're driving along, you see the sign, 20%. What does it mean? It means that for every 100 meters, you go 20 meters up that. So what's the average slope of the hill? It's the rise divided by the run. 20 over 100 is the average slope of the hill, is 20%. Now we can see what happens to average cost as output increases. At first, the rays get less steep, average cost is falling. And it goes on falling, the rays get less and less steep to, in my case, about 15 units of output. Average costs fall. But if you make more than 15 units of output, the rays from the origin to the total cost curve get steeper again. So at 20 units of output, average costs are now rising again. So given the shape of the short-run total cost curve, the average cost curve must be U-shaped. There's one more idea about short-run costs that is very important, and that is marginal cost. And it's going to be crucial to understand the way in which the market system works, that you understand precisely what is meant by marginal cost. The marginal cost is the extra cost of making one more unit of output. Given that I'm making 5 units of output each week, how much extra would it cost me to make 6? Given that I'm making 15 units of output, how much extra would it cost me to make one more unit? The marginal cost is the change in the total cost associated with one more unit of output. And the marginal cost will be different according to the amount of output we're already producing. Going from 2 to 3 units of output will involve a different additional cost, a different marginal cost from going from, say, 18 to 19 units. So what we now want to do is to plot the relationship between output and marginal cost. And marginal cost will be crucial to us in understanding how pricing gets determined. So let's now see if we can work out the marginal cost. Marginal cost, the rate of change of total cost, can be found by looking at the slope of the total cost curve. The slope of the total cost curve, the tangent to the total cost curve at that point, determines the marginal cost. And as we increase output, you can see that the slope of the total cost curve gets less and less. That is to say, marginal cost is falling. But beyond some point, as the law of diminishing marginal returns sets in, the slope of the line gets steeper and steeper and steeper. Marginal cost will rise. So marginal cost is now going to rise and rise through the bottom of the short run average cost curve. So this is short run average cost. Here's my short run marginal cost. Why did I draw it so that marginal cost equals average cost when average cost is at its minimum? Because the slope of the total cost curve, marginal cost, is equal to the slope of the ray from the origin, average cost. Marginal cost equals average cost when average cost is at its minimum. It's important not only to understand marginal cost, to understand the relationship between marginal and average. And some people find it quite confusing because they say, how can marginal cost be rising and average cost falling? We've got a range of output where marginal cost is rising and average cost is still falling. Does that make sense? Well, it does make sense if you think about it with a particular simple example. Think about the marks that you get for your coursework. You hand in your first piece of coursework, you get the mark back, and you've scored 6%. You hand in your second piece of coursework, and the mark comes back, and you've scored 4%. You hand in your third piece of coursework, you get the mark back, and you've scored 2%. What's the average score that you've got for your 3 pieces of coursework? And of course, the answer is very simple to work out. We have 6 plus 4 plus 2 is 12, divided by the number of pieces of coursework that you've done, 3, which gives the answer of 4. On average, you've scored 4%. So the next time you do your piece of coursework, you want to improve your average. You do your 4th piece of coursework, and this time you score 3. Your marginal score is rising. It had been falling. It's now rising. And what happens to your average score? The average is now less than 4. It's obvious that it's less than 4 because the marginal score is below the average score. Had you scored 4, If your average score had been the same as your marginal score, then your average score would have been unchanged. If your marginal score had been better than your average score, then your average score would have risen. That's exactly the same with the relationship between marginal and average cost. If marginal cost is rising, but it's less than average, the average will fall. If the margin equals the average is unchanged. If the marginal score exceeds the average, marginal cost is above average cost, then average cost will rise. So we've now got this relationship between output and average cost, output and marginal cost. Something you could try for yourself is to use the principles that we've developed and see if you can work out the relationship between output and average variable cost. Take total variable cost and divide it by output. And the relationship between output and average fixed cost. Divide total fixed cost by output. But the key relationships, the most important relationships that we need to be clear about is the relationship between output and average cost in the short run and output and marginal cost in the short run, which we've now done. So all that has assumed that the firm is changing its output, but doing it with a fixed amount of land or a fixed amount of capital because it's been in the short run. We're now going to turn to the long run and ask what's the relationship between output and costs when the firm has time to adjust the volume of capital. Now, immediately you should be able to see that the principle which underlies the relationship between output and costs in the long run can't be anything to do with the law of diminishing returns. Diminishing returns is an essentially short-run idea. You're trying to increase your output with a fixed volume of capital. In the long run, you can vary the amount of capital as well as the amount of labour. To put it another way, there are no fixed costs in the long run. You can vary any amount of the resource, so all your costs are variable. So what's the relationship between output and costs in the long run? Now, to do this, we have to remember that we can vary capital as well as labour. And it looks from our studies as if the relationship between output and costs in the long run isn't the same for all production processes. It looks as if there are two main possibilities for the relationship between output and costs in the long run. In the first case, it looks as if for some industries, as output is increased, using more capital as well as labour, costs rise, but they rise more and more slowly. There's a second possibility. It looks as if for some industries, as output is increased, costs rise at first relatively slowly, and then at larger levels of output, relatively rapidly. So let's plot those two possibilities on the same diagram. So in the first case, there are no fixed costs. So at zero output, you're not even in the industry. You have no costs. As output increases, costs rise, but more and more slowly. Long run total costs vary with output like so. In the second case, we think that for some production processes, costs rise relatively slowly, and then at some level of output, they rise relatively rapidly again. So for some industries, long-run total costs looks something like this. Now, there are two things that we want to look at here. The first is, if total costs do that, what is implied about average and marginal costs? And the second question is, why do we think there is a relationship between output and total costs in the long run that looks like that? So those are the two things that we need to think about. So the first question is, if total costs are like that, what's going to be true about average and marginal cost? Now, what I want to do here is to focus only upon one of these relationships between output and total cost. We'll think about the other one in a later lecture, but the one that I'm interested in now is this relationship between output and total costs, where total costs rise relatively slowly and then relatively quickly. If total costs look like that, what's the implication about average costs? It should now be obvious. Given that the shape of the total cost curve for the long run is the same basic shape as for the short run, average costs are going to have the same relationship as well. As output increases, average cost in the long run will tend to fall. At large levels of output, average costs will tend to rise. So we've got a U-shaped a U-shaped average cost curve for the long run. It has the same basic shape as for the short run. And what about long run marginal cost? Well, again, if average cost is U-shaped, we know for exactly the same reasons as we developed before, marginal cost will fall, reach a minimum, and rise again. So let's just plot that so that we're very clear. This is for the long run. As output increases, average costs fall. It reaches some minimum, and at larger levels of output, average costs rise again. Long run, average cost. What about marginal cost? Long run marginal cost falls, reaches a minimum, and for the same reasons that we've seen before, as output rises, marginal cost rises, cuts the bottom of the average cost curve, this time the long run average cost curve, so that long run marginal cost bears a relationship to long run average cost, which looks like so. You might like to think about the other total cost curve that we drew for the long run and see if you can work out the implications for average and marginal cost for that particular shape of total cost curve. But I want to focus now upon the relationship between output and costs for this kind of firm. We've seen if total costs look like that, this is what we've got for average and marginal. But the final thing we need to think about is why this is the case. What leads us to think that this is the relationship between output and costs in the long run? We've got two halves of our cost structure to think about. The falling part of the long run average cost curve and the rising part of the long run average cost curve. Let's look at the diagram again. Where long run average costs are falling, it's because of what we call economies of scale. As the scale of operations increases and we take on more capital and more labour, average costs tend to fall. When average costs begin to rise, it's because of what we call diseconomies of scale. There are certain things which means that as output rises to a high level of output, it begins to cost more and more on average to produce this output. So finally, what are these economies and diseconomies of scale? Let's think about economies of scale first. There are many examples of economies of scale. We'll just take one or two to illustrate the kinds of things that we have in mind. Why do larger firms find that they've got higher total costs but lower unit costs, lower costs per unit? What is it that gives these scale economies to larger firms. Some of them are financial economies. The bigger firm borrows money more cheaply. For example, if you're a small firm, you go to the bank, you want to borrow some money. The bank, if it lends the money to you, will say, we'll charge you something around 8% over the bank rate in order for us to cover our costs. So if interest rates are, say, 2%, you'll pay maybe 10% a year to borrow the money. The big firm will get charged maybe 2, 3, 4% above bank rate. So they'll get charged an interest rate of 4 or 5%. Why do they get charged a lower rate of interest? Because the bank perceives the larger firm as safer. You're more risky as a small firm. The bank wants a bigger premium to cover those risks. The larger firm gets the financial economies associated with being larger and therefore apparently safer. It's not just financial economies. There are labour economies. Small firms have to have people who specialise in a large range of tasks. The larger firm can have specialists in lots of different areas. These people who are specialists get really good at their job because they've got a smaller range of tasks to focus on, so that there are economies in labour by having a larger firm with more specialist units of labour. There are transport economies. You are a small firm and every week you want to send 50 pairs of socks down to the south. You have a man with a van and he drives down there. Your competitor produces 10 times as many socks. He doesn't send 10 vans down to the south. He sends one guy with a bigger van. There are economies of scale. It costs the large firm more to send the socks, but the cost per pair of socks is smaller for the larger firm. There are economies of scale. Finally, what are the diseconomies? We think that for some production processes, these diseconomies of scale haven't been found, but for some industries they have. What kinds of things are we talking about where large firms find that their unit costs rise? The first one is management diseconomies. The bigger the firm, the more difficult it is to control the organisation. It's more difficult for communications to be effective. Good ideas may be lost as a result of being so large, and so things become more inefficient. The other diseconomy, which is probably quite important, is what the sociologists call disaffection. That's the idea that when firms are bigger, the loyalty of the workforce tends to be less than it is with a small firm. It's not difficult to understand that if you think of an example. You leave with your degree, you get a job with a very small firm, there's only 10 of you. One morning you wake up feeling really unwell. Are you going to get up and go to work? Or are you going to turn over and go back to sleep? And you think, this firm needs me, I'm very important. So you get up and go in. A few years later, you're working for a much bigger company. You feel unwell, you wake up. Are you going to make the effort to go in? You're such an unimportant part of a large organisation. They won't miss you. You turn over and go back to sleep. If this argument is true, what it means is that we would expect that as a firm grows in size, the number of days lost through sickness, the number of days per worker lost through sickness, will tend to increase. And it does. It probably means that you would expect that as a firm grows in size, the number of working days per worker lost through strikes will tend to increase. The boss comes in to speak to you when there are only 10 of you and says things are really tough out there, can't give you any wage increase this year. Okay, boss, we understand. We want this firm to survive. We'll accept that. You work now for a very large firm. The argument is that it's much more likely that you'll say, I'm not having that. If you don't pay us what we think we deserve, we'll go out on strike. If that's true, the number of working days per worker lost through strike action will tend to increase as the firm gets bigger. Does it? Yes, it does. So it's perfectly possible that disaffection causes unit costs in the long run to rise. So let's just summarise what we've seen. There's a distinction between the short and the long run. In the short run, you've got a fixed volume of capital or labour. The law of diminishing returns determines the shape of the cost structure. In the long run, you can vary the amount of capital as well as labour. It's economies and diseconomies of scale that determines the shape of the long run cost structure. The short run and the long run cost structure looks fairly similar, but the reasons behind the shape of the cost curve is actually quite different. We've now got a good understanding of the relationship between output and costs, and in the next lecture we'll use those ideas in order to develop the way in which prices get set.